Alright guys, day 2 of log functions. Here we go. So let's look at our first example, x minus 1. We have a minus 1 inside the parentheses. We know we're going right 1 unit. We went down 5 units. So what this is h, this is k. So my parent point is that normally at 1, 0, we're going to go right 1 unit. We're going to go down 5. So I have a new parent point at 2, 5. My normal asymptote's at y equals 0. To find my new x equals 0, excuse me. To find my new asymptote, I'm going to set this equal to 0 and solve. So I've got x minus 1 equals 0. I'm going to add 1, and I get x equals 1. So my new asymptote, vertical asymptote, x equals 1. So we know our domain's going to start there. So the domain's going to be from 1 to infinity. Range is going to be all real numbers. Alright, so now let's set this equal to 1. So x minus 1 equals 1. We're going to add 1 to both sides, and we get x equals 2. Now, why did I do that? Because what I do is I'm plugging in. If I plug in 1 here, I'm looking at points, right? So plotting points to be able to plot my log function. If I plug in 2, I get 2 minus 1. All right, so the log base 6 of 1. Well, the log base 6 of 1 is going to give me 0. Anything to the 1 right here is 0. Doesn't matter what the base is. The log base anything of 1 is 0. Right? Because 6 raised to the 0 is going to give me 1. So what I do is I set this piece equal to 1. Because that's going to give me 1 more. Right? So I have a point at 2, negative 5. Because if I plug in 2 right here, 2 minus 1 is 1. So I have the log base 6 of 1 minus 5, right? So the log base 6 of 1 is 0. And then minus 5. 0 minus 5 is negative 5. So I have a point at 2, negative 5, which we just found, right? That was my parent point. I'm also going to set this piece equal to my base. So x minus 1 equals 6. So I'm going to add 1 to both sides, and I get x equals 7. Now, why am I doing that? Because the log base 6 of 6, because when I plug in 7, I get 6 inside the parentheses. So the log base 6 of 6, if I take the log base of itself, that's going to give me 1. Alright, so I know those are 2 points that I can get very, very easily. So again, our points, we set this equal to 0 to find the asymptote. We set it equal to 1 to find my parent point. We set it equal to the base to find another point. So I get x equals 7. So I go over to 7, and I know if I plug in 7 right here, I get the log base 6 of 6. Well, the log base 6 of 6 is 1, right? 6 raised to the what is going to give me 6? Well, 1. So 1 minus 5. 1 minus 5 is negative 4. So I have a point at 7, negative 4. So your log function looks like this. Alright, same thing for number 2. Let's find our parent point. So to find my parent point, I'm going to set this equal to 0 to find my asymptote, right? So x minus 1 equals 0. So I know that my asymptote is at x equals 1. Now to find my parent point, I'm going to set it equal to, set it equal to 1. So I'm going to add 1 to both sides, and I get x equals 2. So now when I plug in 2 right here, I've got 2 minus 1. So I have the log base 5 of 1. So again, 5 raised to the what is going to give me 1. Well, no, it's always got to be 0. So 0 plus 3 is 3. So I have a point at 2, 3. So over 2, up 3. Now that should make sense because my parent point went over to the right 1 unit and it went up 3. So it starts at 1, 0. It went over to the right 1, up 3. Bam, there's my parent point. Next thing we're going to do is we're going to set this equal to the base. So x minus 1 equals 5. Set it equal to the base. We'll add 1 to both sides. And we get x value of 6. So I have the log base 5 of 6 minus 1. I'm plugging in this x value. 6 minus 1, which is 5. So the log base 5 of 5 is 1. Right? 5 raised to the what is 5? Well, it's got to be 1. So 1 plus 3 is 4. So I have a point at 6, 4. So your log function looks like this. Alright, moving on to number 3. Number 3, I've got the log base 6 of x minus 3 minus 5. So let's go ahead and find our asymptote. If I look at this, okay, again, I'm going to the left 3 units. Sorry, to the right 3 units, excuse me. So it was normally at x equals 0. Now it's at 1, 2, 3. X equals 3. My new parent point was at 1, 0. We're going to go right 3. 1, 2, 3. We're going to go down 5. 1, 2, 3, 4, 5. There's my new parent point. All right, so I've got a point at 4, -5. And I'm also going to set this equal to the base, right? So x minus 3 equals 6. I'm going to add 3 to both sides. I get x equals 9. So again, when we plug this in, we get the log base 6 of 9 minus 3, which is 9 minus 3 is 6. So the log base 6 of itself is 1. So this becomes 1 minus 5. 1 minus 5 is -4. So I have a point at 9, -4. 9, -4. So it looks like this. I'm sorry, I'm supposed to be writing the domain. For these, the domain is going to go from my asymptote, which is at 1 to infinity. Same thing here. Domain is going to go from my asymptote, which is at 3 to infinity. Range, all real numbers. All right, going on to number 4. I've got the log base 2 of x minus 1 plus 3. Again, we're going right 1 unit, so there's my asymptote. We're going to go up 3, so go over 1, up 3. Bam, there's my new parent point. Let's set this equal to my base, so x minus 1 equals 2. We're going to add 1. We get x equals 3, so I'm plugging in 3 right here. That's going to give me the log base 2 of 3 minus 1, which is 2. And again, that's going to cancel out to 1. 1 plus 3 is 4, so I have a point at 3, 4. Log function looks like this. Domain goes from my asymptote, which is at 1 to infinity. Range is all real numbers. Number 5, now we have a plus sign in the parentheses. What that's going to do is that's going to move it left 1 unit. So my new asymptote is going to be at -1. Okay, if I wanted to solve that mathematically, I'd set this equal to 0 to find my asymptote. X plus 1 equals 0. We get x equals -1. So the asymptote is at x equals -1. Now to find my parent point, I'm going to set this equal to 1. So x plus 1 equals 1. X equals 0. Right, we subtract 1, we get x equals 0. Okay, so if I plug that in, I've got the log base 4 of 1. So 4 raised to the what gives me 1. It's got to be 0. Okay, anything raised to the 0 is 1. So log base 4 of 0, 4 raised to the 0 is 1. So that's going to be 0 right here. So 0 minus 4 is -4. So I have a point at 0, -4. That's going to be my parent point. Again, I could have found that just by my transformations. My normal parent point's at 1, 0. We're going to go left 1 unit, so it's going to be to the axis. And we're going to go down 4. Bam, there it is. Now to find another point on the graph, we can set this piece equal to the base. So x plus 1 equals 4. Subtract 1 on both sides, we get x equals 3. Now when I plug that in right here, I've got the log base 4 of 3 plus 1 minus 4. So I've got the log base 4 of 4 and then minus 4. Well, the log base 4 of 4 is going to give me 1, right? 4 raised to the what is equal to 4. 4 raised to the first power is equal to 4. So we know that this cancels out to be 1. 1 minus 4 is -3. So we have x equals 3, -3. Rough sketch, sorry. Domain, asymptote, -1 to infinity. Range, all real numbers. All right, last one. We're looking at number 6. Again, we're going left 1 unit. So bam, there's my asymptote. We're going to go left 1, up 1. So here's my parent point. Left 1, up 1. My new parent point is right there. Set this equal to the base. X plus 1 equals 5. So subtract 1 on both sides. We get x equals 4. We plug that in. We get log base 5 of 5, which is 1. Plus 1 is 2. So x 4, 2. We have a point right there. Bam. There's your log function. Domain from your asymptote to infinity. Range, all real numbers.